from the website or from your own idea?
Sir, Pinterest, sir, you have given.
Pinterest only. Okay. And others? Amlan, what are you planning?
Sir, I'm looking at the Mjolnir hammer, Thor's hammer,
Third
small
hammer.
version.
Okay. Dimensions.
Haven't really thought about it. You have said to keep it 5 by 5, so I
That's
will
okay.
think.
But in order to look perfect, na, you should
Yes, sir.
finalize the drawing, dimension first in a rough paper. Okay. Then
Yes,
only
sir.
okay you will be able to draw in AutoCAD. Otherwise, without dimension, simply by your judgment, it becomes very difficult, especially in AutoCAD. So first finalize the dimensions.
Yes,
You
sir.
all are smart people, so we'll figure it out anyway. And others, Rubana,
Yes, sir. So I have not started yet,
any
but
planning?
sir, I might make something related to
Jewelry.
prosthetics, maybe.
Okay, okay. And Shyamali,
Sir, I am thinking about an architectural design.
okay, of your own house.
Sir, no, like it's a modern type of something.
Mm, okay, whatever you draw, na, just ensure that it gets converted to the STL file. Okay, that means there is no problem. There should not be any problem while converting to STL format, and problem will be there only when you leave, some kind of thin surface without any thickness. Okay, so just ensure that there is no such kind of surface there, and even if there is a surface like that, you can thicken the surface. We have already learned how to thicken a surface, so ensure that. Then you can give a try exporting the file to STL format. Then of course you have to submit the drawing, the in JPG format only. And when we finalize, it can be like you will be asked to submit the DWG as well as STL file. Okay, so let's wait. Let me give him a call. Hello. Ashish, you can join. We are waiting for you.
Sir, do you have to give the scale,
Scale means
sir, dimensions?
no, no need. In three-dimensional figure, dimensioning is given just to give the other person some kind of idea if he wants to recreate the model. But whatever you are drawing and submitting, that is final, na? So the computer will get to know about the dimensions on its own, so you don't have to give. Mitaxi, what is your planning?
Sir, I yet not finalized the drawing, but looking still searching for a drawing.
Okay. Any other students who have any
Hello,
doubts?
sir.
Hmm. Devarsi, yes.
Sir,
Huh.
sir. Actually, I'm making I'm taking the dimensions very large actually, but
Hmm.
later on I can
You can scale down.
decrease the size, right?
Uh,
Yes, yes.
like how big you are talking about?
30 centimeter by 30 centimeter.
Okay, that is
Actually, the reference frame is that size.
Mhm. Okay, anyway, while printing we can scale down it anyway, but to get rid of that step, I asked you to draw it maximum of 5 centimeter, but it's okay, we can scale it down.
I will only do it, sir. I'll take a new reference frame and scale it down.
No problem. So you are using AutoCAD only, no?
Okay, sir. Yes, sir.
Okay.
But actually, where I'm learning from, they used SolidWorks, so it's very
Okay,
difficult
so
to
have you
follow
downloaded
the
SolidWorks?
steps.
Have you downloaded
No,
the
sir.
software? No.
That is 15 GB, sir. That's why. No, no, sir. No,
Okay.
sir. It's 15 GB, sir. That's why I'm unable to download it.
Do you
Okay,
have the
sir.
latest version of AutoCAD, right?
Yes, sir.
Then there are many videos available in YouTube. Okay, I will share
Yes,
the
sir. But the model that I chose, they used SolidWorks. That's why to follow the same steps, like when they do it in SolidWorks. If it takes one step, then we have to do three steps in
AutoCAD.
AutoCAD.
Yeah, that's what I said in the beginning.
Yes, sir.
That AutoCAD is like very tedious, but it is also very accurate when it comes to accuracy. Okay,
Yes.
so
Yes, sir.
uh, Fusion 360 is almost like Solid Edge or SolidWorks. So we will request our resource person to teach a bit about Fusion 360 as well. Fusion 360, if you learn, it is from the same family as I said, from the AutoCAD also only. So if you have already registered for AutoCAD in Autodesk, so the same using the same user ID and password, you can download Fusion 360. And let's not you know wait further, and you can start downloading by today only. So if you start downloading, then not required, because the ID is already activated, I think, that user ID and password with your iCard. So directly you can download and
Sir, I have
start
a
working. Cracked version of AutoCAD or
I have a
Fusion 360?
cracked version of AutoCAD, sir.
AutoCAD. Okay.
Not registered.
Which one? Which version?
2021.
2021. Okay, very good. Maybe would you like to share the link?
Okay, sir. So it's pretty easy, sir. It's in the Get Into PC
Okay.
website.
Okay.
Okay, I'll share it, sir.
Thank you.
Yes, sir.
So regarding the visit, will it be okay for you guys, or I am just give some kind of commitment without asking you? Now no one will join. Will it be a situation like that? Is it or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Sir.
From the people from the Guwahati, there will not be any major problem, but the ones who are outside Guwahati, what will be your plan? Will you skip, or you are already staying in the AC campus? Because hostels are officially open from today, isn't it? AC hostels and PGs are already functioning from the last 2-3 months, so there should not be any problem, I think so. And the only problem will be you will not be allowed if you have not attended the classes regularly. I am not going to take 72 students, that is for sure. So 30 or 35 students will be selected based on your attendance only. So Aashish, welcome. Okay, you can start. Whatever are we going to learn today?
1 second, sir. Give me 2 minutes.
Yes, Ashish. Huh. You can reschedule it anyway. Just cover the things there mentioned there. Other things you can reschedule according to you. It's okay. You can show the software whatever you have planned. You can show. Okay, that's good. Uh-huh. Uh-huh. Mm-hmm. Mm-hmm. Okay. Okay. No problem. No problem. You can carry on accordingly.
Hello everyone. So today we have around 29 students. Yesterday it was 36. So day by day it's decreasing. It's a good sign actually. Only the interesting students are there.
Yes, it's a very good sign.
Okay, no problem, sir. Today students will learn about one more software that we use and which is very powerful. The software's name is Fusion 360. It is a 3D modeling software, and in this software there are lots of tools available to easily identify the problems, and even it's very powerful to make designs. There are lots of things that you can do here. I'll give you some specs what we can do, and later on after that we'll learn about the slicer softwares, how we print a part, and what are the problems that we face in printing parts. We have some samples ready for you. I'll show you some samples also, and we have some files going on, files printing right now, and I just recognize that there are some problems in the prints, and I'll tell you why those print, what are the problems were there in the print. So I'll be able to show you some aspects of 3D printing directly. To begin with, there's a software called Fusion 360, and I'll show you. This is an AutoCAD, Autodesk software only, and it is used by engineering students, and it's very powerful. I'll show you a little bit of that. So in the screen, this is a Fusion 360 software. It is right now I'm using the education license, so it's freely available. You can just download it and use it in your computer. It can be Linux, or you can download it for Linux, Windows, or for iPad. Sorry, Apple also. So first thing first, in the AutoCAD software, you must have heard about how do you design a thing. So let's say, suppose if I want to create any object or anything in this, I need to create a 2D sketch first. So in that, this is a create sketch option. When I click the create option, it asks me in which plane do you want to create the sketch. Let's say I'll choose this one. So right now in this screen, I can use there are number of tools available here: rectangle, circle, arc, polygon, and there are lots of other patterns also there. So in this software, what is powerful about this software is, let's say, if I have to design a rectangle, circle, let's say take a circle. Here you can, in the dialog box, you can calculate it. Let's say you are working in centimeters. So I'll say 10 centimeter, 10 centimeter plus plus 1 inch. So you can do that. It will directly calculate it. Okay. After that, this is circle. This is I. This one is 17 inches. Now suppose if I want one more circle, let's say this one, I'll create one more circle. You want this circle and this circle to be aligned or to be in the same height. So you can adjust that. How to do that? Let's say this. So it should be concentric to this circle. Suppose if I move right now, if I move this circle, the inner circle, even the outer circle will move. Okay, sorry. Okay, what happened just now? First circle that we made, we did it in the origin, so we cannot move that circle now. It was in the origin. Suppose in the arbitrary value, if I make any circle here, and second, if I make any circle, I want this to be concentric. You can choose this one, and then it will collide. Now, if I want to move any of this circle, suppose if I move this circle, this one, it will move along with the outer circle. So this is a design constraints. There are lots of constraints that we can play around with. And let's say after this, there's a D. You can set the dimensions there. If I set it 17 inches, you can directly write 17 inches. Then if I say that the difference between this circle and this circle is, let's say this and this is 3 inches. So it will increase this one. Now if I want to change the inner circle and make this circle 17 inches, it will directly increase the diameter of this circle as well. So these are design constraints. If you want to change anything in the first part, it will get changed according to the constraints that you have given. Here the constraint is the difference between the first circle and the outer circle is 76 mm right now. After that, using these many tools, circle, arc, polygon, spline, and all those things, we can make lots of designs. After we've made this sketch, if I want to extrude it, you can directly click here and then give an extrude option, let's say 5 mm. And this one, if I extrude it and make it like 350 mm, Okay, sorry, I should have explained. Now suppose this is the first range that we have made. Now what we want one more cylinder on this part. So what we'll do, we'll use this sketch option, and as I said, you have to select a plane. So you can select this plane, the bottom plane, or any other planes like this one, this one. Now we want the next design to be on this plane. So I've made this using this same center. I've taken two more circles. Let's use offset. This is an offset option. You can directly choose this one, and you can make an offset. Suppose if you want the difference between the walls to be 10 mm, 20 mm. So this, let's say we have made this 20 mm. We'll do this finish sketch. Again, I'll press E for the extrude thing, और हमने ये बना लिया. ठीक है. Now let's say अगर आपको डिजाइन आपने जो सर्कल सोचा था, जिस the first circle that you made, you want some changes in that, and you don't want to repeat all the process again. And so what you can do is directly go there. There's this, you can see in the bottom, this is the history panel. So if you go back to the first sketch, you are here. Now if you want to edit the sketch, edit sketch, and let's say this one, if I increase to, let's say 25 inches, and I just want to 5 inches. Now when I finish the sketch and finish the, again take it to the final part. So this is the sketch that we got. So you don't have to worry about the design dimensions at all the point. You can just make changes by going into the history. This is the only software I think where it works. Uh, uh, Suppose if you make any part and you have made some mistake, or your values are changed, or you found that आपको कुछ भी change करना है, उसको आप आराम से history में जाके आप उसको change कर सकते हैं. ठीक है. Sir, do you have any design that you're working on right now? कोई भी assignments या फिर कुछ भी दे रहे हैं?
We have shared some assignments, not assignments, practice drawings. So yes,
Okay.
will it be better if I share this here, and it will be, means you can refer to those diagrams?
Yes, sir.
Draw one. Okay, I am just sharing again in the group. Okay. Whatever you feel like, you can. Okay.
Let's
That will be a very simple one, I think.
let's take one. Well, let's take one design. Is this a camera? Let's take this design.
Yeah.
Okay. So I'll be able to explain you much better if I can, if we consider this design. So I'll just download it. I'll delete everything. And we'll start from scratch. I'll be able to.
are not audible, Ashish. Hello, Ashish, can you hear me?
Hello?
Yeah, now you are audible.
Oh, my voice was
Hmm.
not there. Okay, okay, okay. Okay. So we will be designing this image, this part now, and I'll be able to explain you the software features in a much better way, and you'll be able to connect it. So I've downloaded this image, and using you can add that photo in the canvas option. To do that, you can go to the insert option, add canvas, to select a plane where we want to make this design. We can scale it. Okay. You can adjust the canvas visibility here, opacity control. Let's make it 7%, 100%. Okay. Okay. Now let's create a sketch. To make this part, initial part, the first bottommost. After I've selected the sketch, you have to select a plane. I'll select this plane. This is the pan option. Uh, to move, you can just click this pan and you can pan around. Otherwise, what you can use, you can directly use the center, the scroll, the scroll in the mouse, click that, and then you can drag it to pan around. First of all, let's say this is 26 mm. I think it's in mm, right?
Yes,
This
yes.
is 26, this is 44, this is 34, 17. Okay. And this is similarly the same. So what you can do, directly take a rectangle. You can start with anything. Now pressing the D, D is stands for dimension. Pressing the D letter, I can set the dimensions here. So I want it to be 26. Let's make it in cm, centimeter. Not too much. Okay. 26 mm. Very small. Not, and just decrease the canvas size. So you can always change your previous calculations while by going back in the history. So using the D option, the size, okay, this sketch. This is 26. Next, this is 44. So D 44. Okay. One more rectangle. D. This is 20, 34. 34. And this one is 17. Let's make it 17. This is 17. Similarly, you want this design. This rectangle stands still here, I think, yes. So you can make one more rectangle. There. Now let's make, there's an option called constructions. Line type construction. So using this option, you can make lines just for your reference. So I've taken a line, I make it a construction line, and Do you see a um, triangle coming? That indicates that this is the midpoint of this line. So I'll just press this and I'll connect it till here. Now, since our design is symmetrical here, this basic design is symmetrical, this part and this part, I can just mirror it. So what I'll do, there's a mirror option, mirror. Using this mirror, I'll mirror this part and I'll select the mirror line. This is the mirror line. So I've got another line. So if I check the dimension of this is 17 mm. You cannot change the direction of this part since this is a mirror of this part. Now if you change the dimension of this one, let's say we'll make it 18 mm. So even this will increase. Even this got increased. Okay? So these are the constraints. So you can use constraints with, and you don't have to make changes every time. Okay. After that, I think they have extruded it 16 mm. 16 mm. So we'll finish the sketch, and we'll use extrude option. Extrude option. E. We'll select the planes that we want to extrude. So we have to extrude 16 mm. So this is the positive direction. You can even extrude it in the negative direction. So you just have to give the command minus 16 mm. Okay, we've extruded 16 mm. After that, this is 44. Edit feature. This one, this is 44. This is 26. This is 17. This is 34. Okay. Now we want to cut this part. So what I have to do, I have to take a sketch. I have to choose the plane. This is the plane. This one, this is for this. This one is the plane. So I have to take a rectangle. This centimeter is 25 mm. So the dimension is 25 mm. So I'll take a rectangle to make it 25 mm. This is 25 mm. And radius is 9. So this dimension will be 18. So I can use this one and make it 18 mm. Okay. Now you can use one more constraint, midpoint. This is the midpoint constraint. Midpoint of this part is midpoint of this part. Did you see what happened? Hello?
Sir.
Can anyone reply? Hello?
Yes, sir.
ठीक है, समझ में आया ना कि कैसे मूव हुआ. हम लोगों ने मिड पॉइंट इसका सेलेक्ट किया एंड इसका सेलेक्ट किया. इसका मिड पॉइंट सेम है. सो सपोज इफ यू, अगर हम लोग इसको इंक्रीज भी करते हैं, लेट्स से कि हम लोग ने इसका इंक्रीज किया, इसको अगर हम लोग 20 इंक्रीज करते हैं तो दोनों तरफ से 1 mm इंक्रीज होगा, है ना, बिकॉज देयर इज अ कांस्टेंट 18 mm. Now we want this semicircle arc. So I'll take this one. So in circles, there are various types of circles that you can make. You can make a circle using a center. You can make a circle using 2 points. You can make a circle using 3 points. So let's make a circle using 2 points. First point is this one. Second point is this one. So we have an 18 mm circle. Now we want to cut this part. So what do? We'll finish this sketch and we'll extrude it. So we'll extrude it in negative manner. So in extrude option, there are three options: join, cut, intersect, and new body. So if I take it in this direction, it will use join. If I take it in the opposite direction, it will automatically convert into cut. You can also make it a new body or an intersection or join. So in our case, we have to cut it. So we'll use cut. And what is the difference? How much is the depth of this part? This is 12 mm. So we have to make it minus 12 mm. Okay. Other than that, what? Okay, okay. So we've got this shape first. Okay. Now we'll cut this part. This will make this shape, and this shape. So we have this dimension. This is 15 mm and this is 9 mm. So what I'll do, I'll make a sketch in this plane. I'll make a sketch here. This is 15 and this is 9. We're making a sketch here. So we'll make a construction line. Any construction line. This is a construction line. Let's make this as construction. Okay. And then we'll make one more line. This one. So we know the distance of this line and this edge is 15. So we can make it at 15 mm. And we know the distance between this line and this line is 9 mm. 9 mm. Now we have to cut this part. We have to join this part. So we'll take a line. We'll off the construction part. We'll use this snap and this one. Now we got this part. Now what I can do is I can use extrude to cut it. Cut this whole part. What you can do is you can directly drag it and cut it till here. Or else what you can do, you can give a dimension, let's say minus 20 mm. So it will cut here. Otherwise, other than that, you can also do one more thing. You can just choose, instead of use distance, you can choose two object. If I choose two object, I have to click a face. If I click this face, it will cut till here. 17 mm. We know the width of this part is 17 mm. So it has taken a value of 17 mm because we've used two object. Okay. Similarly, I can edit this sketch again. Edit sketch. I know this is the midpoint, so I'll make a line. This is the midpoint. Okay. Now we'll use this line as the mirror for this object. Mirror. We want this to be mirror on this mirror line. So this is the line that we've got. Okay. Now this is the extrude feature that we used, which has cut only this part. If you want to go and edit this feature, edit feature, now you can select one more profile. Let's say you have selected this profile. Profiles. Okay, now it looks like that. Otherwise, you can what you can do is you can use this feature. I'll complete this part. Let's put this part. Select this. This is mirror line. Extrude. Okay, and there's some mistake here. I'm not able to convert this using this sketch. Edit sketch. Make point. Snap. Now, hello. So we'll adjust this extrude part, edit feature, and we can select these two together. So now you can cut it. We'll bring this sketch, edit, feature, this one, we'll tell her. Now we've got this part, we've got this part, we need to make this one. This is an extrude of 6 mm first, and 6 plus 10. This is 6 and this is 10. So we need a 16 mm extrusion of this block. So, and this is 35 mm. The width of this part is 35 mm and it is at the center. So what you have to do, you have to make a sketch, choose this plane. This is 35. So I have to make a rectangle. D. Sorry. This is 35. I have to choose midpoint. Midpoint of this. X. This is a part, and we'll take a rectangle. Make one more rectangle. Choose the dimension as 35 mm. I'll take a midpoint of this part and midpoint of this. After that, I need this to be collinear to this part. So this is collinear now. What we can extrude this part, and the extrusion is 6 mm plus 10 mm. So 6 plus, you can always calculate in the dimensions. 10 mm. or otherwise what you can do, you can also extrude it at only 6 mm. Let's extrude it only 6 mm. 6 mm. Now we are in this plane. We have to make one more rectangle. So we'll again create a sketch. Use this as the plane. We'll take a rectangle that is 32 plus 10, 42. 42 and white. And the width is 35. So right now we are in this plane, the top plane, which is 10 mm wide. So we'll again extrude it. We can use this to, you choose this just to profile, extrude it 10 mm. Now you see there's a curve here in this part. The radius of this curve is 8. So to give that curve, what you have to do, you have to choose fillet. Choose fillet, select the part that you have to, and then give the value 8 mm. 8 mm. So this is the part that we have right now. After this, there's a hole. There's a hole which is at a distance of 12.5 mm from this part. So use this sketch. If we edit this sketch, we'll see this is 42 mm. This is 42 mm from here to here, and then 10 mm, 10 more mm otherwise. So now we have to make a sketch that is at 12.5 mm from the corner. Okay, we have to increase this to 52. 52 mm. And we have to make a line which is at a distance of 10 mm from the edge. D 10 mm. Finish sketch. If you see, if you edit this feature, we'll see that there are 3 profiles selected. 1, 2, and 3. These 3 profiles are selected. So what I can do is I'll just delete this profile and I'll select these 2 profiles as 10 mm. Okay. Now we have we can switch on and off the sketches from this part. So we see that this part is 6 mm extruded and this part is 20 mm. So this part is 10 mm extruded and this part is 20 mm extruded. So again, I'll use extrude command E and I'll select this part and I'll make it 20 mm. Here the part has been joined. We can also use cut or new body, but the part is joined there. Now we have to cut this circle. To cut that circle, we have to make a sketch on this plane, and that is 12.5 centimeter from this part. So I'll just make a circle which is 20 mm in diameter. 20 mm in diameter. I'll use D to give the dimension. That is 12.5 mm. Okay. So I'll use this extrude command to cut it. You can directly drag it to cut, or also you can use 2 object to cut it till where you want it. Now, so we have a circle here, which is whose radius is 8 mm, and we have a circle here in the back whose radius is 13 mm. So what we'll do, we'll select a sketch, we'll this is the plane for making the first radius. This is the plane. So what I'll do, I'll make a radius of at the midpoint. I'll make a circle whose diameter is 16 mm. This is the first plane, and till where do you need? Till here, and the diameter for that circle, you have to again make a sketch, and you have to choose this plane. We can create a radius. This diameter is 26 mm. So now you see there are two sketches in two different planes. So there's one more command called loft. Create loft. Loft command is used to join two sketches. So here, using this loft command, I'll select this one profile and this profile. So you see how it has come? Okay. So I think the design is ready.
Sir, how can we rotate the figure?
Rotating this figure, like as in
The whole figure.
you want to rotate this whole figure.
Yes, sir.
Okay. You cannot if you try to rotate this figure. We have made lots of sketches in different planes, so we won't be able to rotate this figure. Let's see if I try. Face, bodies. You can rotate this figure. Is this what you're asking?
Yes, sir.
Okay, you can rotate it, yeah. But suppose if you try to rotate this figure, the constraints that you have used, you have to be careful about that. So even if we have rotated this figure, let's say we have rotated 30-degree. Okay. So now if you want to go and change this part, if you go and edit, this will be like this. And because there is a command of rotate, we've given a command of move. So it will always do that when you go back, like when you go back to the present point. So if you like, I'll just delete it for now. Yeah. Okay. Anything else? So this is the design that we've made today. This is what you are looking for. This is what we have designed. Now, if you want to check if the designs are right or not, what you can do, let's just go. From design. Create drawing, full assembly, create view from scratch, ISO. Okay. Okay. the angle that we're getting is not according to what I want. So what I have to do, I have to change the first sketches. I have to redefine the sketch plane. So if I redefine the sketch plane and if I select this option, this plane, the design remains same. No, there are mistakes here. So just go back. So we cannot do that. To sketches. Have it now. View isometric southwest isometric northwest. West. Let's make it this part. Scale is 1:2. Switches. Close. Projected view. And here. Yes. Okay. So this is the design that we're looking for right now. Dimensions. Dimension. Let's see. Sorry, actually, I forgot how to check the dimensions.
It's okay, Ashish. I think you can
Okay, sir.
export the STL file and
Okay. Now we'll export this file.
yeah.
Okay. So what I want to tell you is like even if we want to change it, suppose let's say you got it like this is right now, this is our radius of this part is 9 mm. Okay. So we have to search, we have to like if you click this part, these are the features that will get highlighted. So this feature explains the this extrusion part, and this feature explains the extrusion of this part, whole part. So if you edit this part, if you want to edit this part, you can edit feature, and if you want that, if you know that, if you found that ये 12 mm नहीं, it should be 11 mm or 10 mm, अगर आप इसमें कुछ changes करते हैं, let's say make it 10 mm, you make it 10 mm, so it'll all everything will remain same जो भी जिस कमांड से आपने इसको बनाया है, so again it will automatically calculate everything. So अभी ये जो है ये 10 mm का डिफरेंस है. Now suppose if अगर हमारे को एक वापस अगर एडिट करना है तो I can edit it multiple times. same here. So this is what you have got. ठीक है अभी we can export this part. Let's export this part. To export it,
Hello, sir.
go to the, hello. Huh?
Hello, sir. Sir, I have a question, sir. Sir,
Ask
can
me.
you scale down the whole model?
Scale down the whole model. Yes, you can. There's an
Sir, can
option
you
called
show?
scale. You can using the scale. You can scale it here itself, or we can scale it in the slicer software as well.
Okay, sir.
Okay. So we'll export it from here. Go to the design file, 3D print it. 3D print. Select the model. Sending it to utility means if you have a computer, if you have a 3D printer directly connected to your computer, you can use this to send it to the utility directly. Otherwise, you have to uncheck this part. Now you can export this model into an STL file. So let's say I've exported it to. So we have that design right now. Now we'll bring it in Cura. Cura is a slicer software that we are going to study today.
Is it open source, Ashish? Like,
Yes, sir. This is an open source software, and it's a software from Ultimaker company. Ultimaker is one of the best 3D printer making companies
okay.
in the
The
world,
students
and
can download the software and practice, right?
yeah. So Ultimaker has various 3D printers available, and they have also developed this Cura software, and they're working on multiple dimensions. They're also creating some websites where you can directly upload your designs and get the file printed from best possible vendors that are around you or around the world. So
So you have used
and
Slicer, Simplify 3D, and Cura as well.
Simplify 3D is not an open source slicer.
Okay.
That's a paid version, and there are some features in Simplify 3D which is not available in Cura right now. Um, so like that's why like for professionally we have to use Simplify 3D. Otherwise, Cura is also a very powerful software where you can adjust everything and anything.
Better than Slicer, right?
Better than Simplify 3D, you're saying.
No, Slicer, that Slicer software, SLI,
So
SLI.
Cura is also is a slicer software. Simplify 3D is also a slicer software.
No, no,
दोनों slicer
Slicer.
software पे
Yes,
हैं.
I know that's a
Cura
Slicer software.
is an open source. Simplify 3D is a paid version.
Actually, there is a software
Q,
called SLI 3 CER. So that's a different software.
okay, yeah, yeah, that
Nothing is
software is also
SLI 3.
available. That is also slicer software. Cura is better than that.
Okay, okay.
ठीक है. ठीक है. Now in this Cura settings, we can select the printer that we want to print in. So what we'll print it in Pratham 3D printer. Add Pratham 3D printer. Every printer has their own like dimensions. So Pratham, that the printer that we are using right now is a Pratham software. Pratham is again Indian brand software from Make 3D. We are the distributors of Pratham 3D softwares. We are also a distributor of Ultimaker printers. But right now we'll make it in Pratham 3D printer software.
So if the printer is not connected, okay, with the PC, then will these options pop up?
Yes, sir. Even if the suppose any student he has made any design and he wants to print that, so it's not necessary that he has to has a printer. He can directly send the model to the vendors, or he can also send the G code. G code. So what we'll do today, we'll tell you how to make the G code. So G code is everything actually, because there are lots of settings available, and according to your concern, you can generate a G code, and you will get to know how much gram, what is the weight of the printed part, and you'll also understand what is the uh, time taking, like how much time will it take to print that part. So if you know how to generate a G code, अगर आपको ये पता है कि जी कोड किस तरीके से जनरेट करते हैं, तो आपको मालूम रहेगा कि वो 2 घंटे में बन रहा है या 2.5 आवर्स में बन रहा है और 5 आवर्स में बन रहा है. सो द वेंडर कैन नॉट चीट यू. लेट्स से कि आपने एक डिजाइन भेजा, यू डोंट नो हाउ टू जनरेट जी कोड, तो आपने कहा वेंडर को सर इसको प्रिंट कर दो. वेंडर ने आपको कहा कि सर दिस विल टेक अराउंड 5 आवर्स टू प्रिंट. ठीक है, बट सपोज इफ यू नो how to generate a G code, you'll be able to generate a G code and you can find out if he's right or not. हो सकता है वो आपको 5 घंटे बोल रहा है, वही पार्ट आपको 2 घंटे में बन रहा हो, तो वो चार्ज आपको भले like he'll say that we are charging 150 rupees per hour and market rate is 200 rupees, but what he'll do, he'll increase the timing. Let's say कि 4 hours लग रहा है, तो he'll say it's taking 6 hours. So you will, if you know how to generate a G code, you won't be, they won't be able to cheat you. ठीक है, so let's understand how to generate a G code and what are the designs, what are the parts that you need to focus on. First of all, uh, this is the machine settings. Every machine has a build volume. Build volume. Build volume is a part. What is the maximum size a printer can print? So Pratham 3D printer, it can print 30 30 centimeter by 30 centimeter by 30 centimeter. X direction 30, Y direction 30, and in Z direction also 30. Okay? It has a rectangular build plate and heated bed. What is heated bed? There are many types of 3D printers. Heated bed, the build plate of a printer. I'll just show you. I'll connect. I'll get. Sorry. I'll join the meeting from my mobile. Okay. So that I can show you printer. Okay. I'll show you printer. Inas. ये लैपटॉप लेकर आऊँ यहाँ पे, ये लैपटॉप लेकर आऊँ मेरे को. Okay. So this is a 3D printer, a Pratham 3D printer. This is the, you see this glass bed. Am I clear?
Yes,
Yes.
definitely.
Okay. So yeah. So this is the build volume of the printer. Build plate. This is called the build plate. There's a heater in it. This build plate has a heater connected to there. And this is the extruder part. This is the extruder part. Yesterday I told you, explained you about the extruder. This is the heat block where the filament is getting melted. And there's a nozzle below that from where the materials are getting extruded. Okay. This part has this. It's already 6.5 hours since it's printing. It has like LCD shows you that it has completed 76% of its print, and it will. I think around 1 or 2 hours are still left. So basically, I want to tell you that this is the build volume of the printer. Every printer has a different size of build volume. According to build volume, the price of a printer varies. This printer has 30 by 30 by 30 centimeter build volume. Then this printer, this one has 20 by 20 by 250 mm. It also has a build plate. And similarly, there's one more printer which has 150 by 150 centimeter and 150 in Z direction. Hello. Okay. So build plate. Every printer has its own build volume. One second. Excuse me. हाँ. तो according to the printer, आपको build volume select करना है. And after this, we'll just directly understand the slicer software. So you remember we have exported the STL file from the Fusion 360, this part. Now we'll import it in Cura software. Using the import command, we've exported this to our, we've imported this to our slicer software. One of the most important aspect is to understand in which orientation do you want to print a part. So suppose if you're printing this part in this orientation, you see these red spots. This red spots indicates that this part will need supports in this part. This body will need supports in this part, the red spotted parts. So if I generate support structures, slice it. We'll see these parts. You can see that these are supports. These are supports. In Cura, actually, the visualization, the UI is not very good. So I think I should show you Simplify 3D simultaneously. Okay. So one of the most important thing is the orientation of a body and how you want to print it. Suppose if you're printing in this part, so support generated. These are the supports that we need to print this part. Otherwise, this part won't be. You won't be able to print this part without the supports. And similarly, if I make one more part, and if I print this in a different orientation, if I print in this orientation, let's check the where are we getting supports. only in this part. So it depends how you print it and what do you need from a printed part. Yesterday we learned till here. Um, excuse me. Can I have a break of 5 minutes? I just need to revise everything and then like I need to sort out everything and I'll let you know. कैसे
Sure,
होगा
sure,
कहाँ से.
Ashish.
Okay, sir.
Till then, students try to download this Fusion 360 as
Fusion
well.
software. Yeah. Hello, students. Next, what like I think Instead of Cura, I'll explain you using Simplify 3D because it's better to explain in Simplify 3D. The visualization is better, and there are not much difference in Cura and Simplify 3D. Once you understand Simplify 3D, the terminologies that we use in using while we generate a G code, once you understand that, it will be much easier to understand Cura software. So directly teaching you Cura, it's a little difficult for me right now through online class, but I'll be able to explain you a lot of things in Simplify 3D, and then we'll understand Cura later on. Okay? First of all, the first thing to consider is the orientation of a print. So as I said, like if you print in this orientation, there are lots of supports that are being generated, and if you print in this orientation, there's very less supports. The lesser the supports, the better is the print. The lesser are the supports, the better are the prints. So, and what is how does it affect a print? Like if you're using more supports, if you're using more supports, it might take more time to print it. So if I want to print in this part, in this direction, let's say if I delete this part, using the same settings, this part will take around 2 hours 51 minutes to print. 2 hours 51 minutes to print. And the weight of this part is 37 grams. And suppose if we change this orientation, now this part will take 2 hours 18 minutes to print, and it's much clearer print. But all the details are clearly visible, and there's only supports being generated in this part. So the part where the supports are being generated won't be very smooth using an FDM printer. जहाँ पे supports बन रहे हैं वो part आपको बहुत smoothly नहीं मिलेगा. So you have to understand that lesser the supports, it's a better design. ठीक है. Now you've understood what is supports, the orientations. In edit process settings, there are multiple points that you need to understand. Similarly, in Cura also, there are lots of, you can change the dimension, rotate. This one. Similarly, there are settings here. As I told you about the quality. Quality stands for the layer height. Layer height is nothing but the resolution of a print. आप कोई photo खींचते हैं, there's a resolution that we calculate in megapixels or pixels. So similarly, in 3D printing, layer height is the resolution of a print. Layer height is nothing but the resolution of a print. So we can change the resolution. Using an FDM printer right now, as I showed you in this Pratham details, machine settings, the build plate of this is 300, 300, 300 in the extruder. The extruder, there is a nozzle size. So you can change the nozzles. Right now, the standard nozzle size is 0.4 mm. 0.4 mm is the standard nozzle size. And the compatible diameter of the material is 1.75. Yesterday, someone asked me, can we recycle a part? Yes, like as I told you, कि हाँ हम लोग recycle कर सकते हैं, but जो recycle करके जो wire बनता है, अगर उसका dimension 1.75 से vary करता है या 1.85 होता है, So it has to match which is the printer compatibility. So Pratham and the maximum printers are compatible with 1.75 mm diameter of the raw material. There are some printers जहाँ पे 1.75 की जगह 2.85 mm यूज होता है, like Ultimaker. So it doesn't make any difference if the material is 1.75 mm or 2.85 mm. It won't make any difference in the print, neither in the printing time. Just keep the systems, the hardware of that printer is designed in such a way that it is compatible 1.5. It is compatible with 1.75 mm or 2.85 mm. No much difference, but we have to make sure that the raw material is 1.75 mm throughout. ठीक है, to that layer height according to 0.4 mm. ठीक है, तो I told you कि that maximum height that you can print will be 3/4 of the nozzle size. So if you are using 0.4 mm nozzle, the maximum height of a layer height, the maximum height that we can use is 0.3 mm. Initially, so to simplify that, I'll show you something using this. .3 mm. Okay. What happens if you print in 0.3 mm? Print. So if you can see this part, these are printed in 0.3 mm diameter. And if you change this layer height to 0.1 mm, you see the smoothness. स्मूथनेस में आपको फर्क पड़ा, समझ में आया कि यहाँ पे okay. The image that you're seeing is this has been calibrated in 100 micron. 100 micron में आपको डिफरेंस दिखाई दे रहा है. 200 micron, this is in 200 micron, this is in 300 micron. तो आपको डिफरेंस दिखाई दे रहा होगा कि किस तरीके से हमारे को फर्क पड़ रहा है. बट यू नीड टू अंडरस्टैंड देयर इज नो मच डिफरेंस व्हेन द पार्ट इज फ्लैट. यहाँ पे जो पार्ट है, ये जो फ्लैट सरफेस है, उसमें अभी भी कोई फर्क नहीं पड़ रहा है. दिस इज फ्लैट हियर if you're using 0.1 mm, and even if we use 0.3 mm, this will be same. ये सेम रहेगा, इसमें कोई फर्क नहीं पड़ा. बट दिस पार्ट हैज अ डिफरेंस. सो लेयर हाइट will decide the resolution of a print, but only if it has a slope or a curvature. If the part is straight, it won't make it. It does make a difference, but उसमें कोई उतना फर्क नहीं आता. It's not so visible. बट अगर कोई स्लोप है तो यहाँ पे विजिबल होगा. जैसे अब ये 0.3 mm है, आपको इस तरीके से दिखाई दे रहा है. अगर हम उसको चेंज करते हैं एंड 0.1 mm देते हैं, तो ये सी द डिफरेंस कि काफी स्मूथ है. ठीक है, तो लेयर हाइट से लेकिन क्या फर्क पड़ा? If you're printing in 0.1 mm layer height, it takes 4 hours to print. It takes 4 hours to print, but it is smooth. But if you print it 0.3 mm, it takes 1 hour 38 minutes to print. So accordingly, you need to decide कि कितने हाइट पे आपको प्रिंट करना है. तो एज I said you कि अगर आपने किसी वेंडर को अपना फाइल जनरेट करके दिया, जी कोड जनरेट करके दिया, यू हैव टू आस्क हिम और यू हैव टू टेल हिम कि कितने हाइट पे आपको प्रिंट करना है. द स्टैंडर्ड साइज टू प्रिंट is 0.2 mm. 0.2 mm is the best quality that we generally use to print any part. and because 0.1 mm takes lots of time and 0.3 mm doesn't give you high detail. So 0.2 mm is the standard that we use. 200 mm. So difference अपने यहाँ पे मालूम चल रहा है कि it takes 1 hour 38 minutes to print this part in 0.3 mm. Similarly in 0.2 mm it will take around 2 hours 18 minutes. ठीक है. This is first thing, layer height. So as the layer height increases, time decreases. As the layer height increases, time to 3D print decreases. As the layer height increases, cost of a 3D printed part decreases. ठीक है. लेयर हाइट इंक्रीज होता है तो रेजोल्यूशन भी डिक्रीज होता है. So these are the 3 points to consider.
सर आई हैव ए क्वेश्चन. सर एक ही 3D मॉडल में मतलब अलग अलग लेयर हाइट यूज कर सकते हैं क्या?
हाँ कर सकते हैं. I'll show you that also, but I'll show that in some other day or like let's say okay भी दिखाते हैं आपको. Let's say कि हम लोग यहाँ पर हैं अभी. If I know कि only in this part हमारे को layer height छोटा चाहिए, otherwise सारा like we can decrease we can use 0.3 mm layer height. So what I can do is I can go to the tools option. There's a variable settings wizard. So I can give a height here. I'll give an okay. सबसे पहले हम लोग यहाँ पे करते हैं. यहाँ पे हम लोग ने एक एड लोकेशन किया. सेकंड हम लोग ने यहाँ पे एक एड लोकेशन किया. थर्ड हमने यहाँ पे एड लोकेशन किया एंड देन फोर्थ हम लोग ने यहाँ पे एड लोकेशन किया एंड स्प्लिट प्रोसेस किया. सो देयर आर 5 settings right now. 1 2 3 4 5. So the first process is for the first part height where the print is stopping at 7.91 mm जो हमारा पहला स्टॉप है. वहां तक हम लोग ने इसको 0.2 mm दे दिया. लेट्स से कि हम लोग ने इसको 0.3 mm दे देते हैं. 0.3 mm. Okay. Then in second part, if we can change it to 0.1 mm. Third part again 0.3 mm. Fourth part again 0.1 mm. And fifth part again 0.3 mm. और let's say 0.2 mm. ठीक है. अब हम लोग प्रिंट करके देखते हैं कि हमारे पास में क्या ऑप्शन है. So this will take around 2 hours 54 minutes to print. So अब आपको डिफरेंस दिख रहा होगा कि यहाँ तक this is smooth, this is wider, but flat है तो हम लोग ने इसको 0.3 mm यूज किया है। जहाँ पे हमारा स्लोप है वहां पे हम लोग ने 0.1 mm यूज किया है। जहाँ तक हमारा फ्लैट है वहां तक हम लोग ने फ्लैट यूज किया है। कर्वेचर में हम लोग ने 0.1 mm यूज किया है एंड अबव दैट हम लोग ने 0.2 mm यूज किया। सो वी कैन यूज दैट ऑल्सो। ठीक है, तो बेसिकली हम लोग सिर्फ यहीं तक समझेंगे आज अभी तक कि लेयर हाइट क्या होता है। लेयर हाइट से हम लोग टाइम वेरी कर सकते हैं। लेयर हाइट अगर इंक्रीज होगा तो लेसर टाइम टू टेक प्रिंट, हायर लेयर हाइट क्वालिटी डिक्रीज होगा, हायर लेयर हाइट होगा कॉस्ट ऑफ द प्रिंट विल आल्सो डिक्रीज। ठीक है, द नेक्स्ट इज इनफिल। Okay. तो नेक्स्ट इज द फर्स्ट पार्ट इज लेयर हाइट। तो लेयर हाइट हमने समझ लिया। आफ्टर दैट वी हैव टू अंडरस्टैंड व्हाट इज टॉप सॉलिड लेयर्स, बॉटम सॉलिड लेयर्स एंड आउटर पेरिमीटर शेल। सो इफ आई हैव टू शो यू, अगर हमने इस पार्ट को प्रिंट किया, इसको हमने डुप्लीकेट कर लिया, से 2 3 यस ओके। फर्स्ट पार्ट इसको so, okay. हर बॉडी के लिए हम लोग अलग प्रोसेस सेट कर रहे हैं, एवरी बॉडी के लिए। ये सिंप्लीफाई 3D में पॉसिबल है बट क्यूरा में पॉसिबल नहीं है। आई एम जस्ट डूइंग टू एक्सप्लेन यू द डिफरेंसेस बिटवीन लेयर हाइट्स, द शेल्स एंड द इनफिल्स। Okay, so first body के लिए this one is body, second के लिए this, third is this one and fourth is this one. So in the first process settings हमने layer height सबके लिए सेम रखा है 0.2 mm। फर्स्ट वाले के लिए हम लोग ने टॉप सॉलिड लेयर्स 3 है, outer perimeter shell is 3 and infill is 30, let's say 30, no, it's 20, let's make 20 mm, 20%। okay, सेकेंड सेटिंग मॉडल के लिए हम लोगों ने नंबर ऑफ शेल्स को इंक्रीज किया है 5, इनफिल हम लोगों ने रखा है 40। थर्ड वाले के लिए हम लोगों ने लेयर का टॉप सॉलिड लेयर को हमने डिक्रीज कर दिया है 0, number of shells is 4 and infill percentage is 40. This is rectangle, can make it triangular। फोर्थ पार्ट के लिए हमने लेयर को चेंज कर दिया है, बॉटम सॉलिड लेयर 0, इनफिल इज 80%। Let's print these parts। Okay, so this is 1, this is 2, this is 3 and this is 4। सबके लिए हमने पॉइंट लेयर हाइट हम लोग ने 0.2 रखा था। फर्स्ट वाले में हम लोग ने इनफिल रखा था 20% एंड सेकंड वाले के लिए हम लोग ने इनफिल रखा था 40%। सो जस्ट सी द फर्स्ट एंड द सेकंड मॉडल, क्या डिफरेंस आ रहा है। फर्स्टली नंबर ऑफ शेल्स, दिस इज कॉल्ड आउटर पेरिमीटर शेल। जो हम लोग ने यहाँ पे देखा ये सेटिंग्स में, यहाँ पर है हमारे सेटिंग्स आउटलाइन पेरिमीटर शेल नंबर 2 जैसे यहाँ पर है। तो फर्स्ट प्रोसेस सेटिंग्स के हमने लिख के रखा हुआ है लेयर आउटर पेरिमीटर शेल इज 3। So this is the outer perimeter shell 3. ये जितना ज्यादा शेल्स होगा उतना आपका बॉडी स्ट्रांग होगा. नंबर ऑफ शेल्स इंक्रीज करने से आपका बॉडी जो है वो उतना स्ट्रांग होगा. जनरली 3 to 4 इज इनफ. हमने यहाँ पे शेल रखा था 3, यहाँ पे हम लोगों ने शेल इंक्रीज किया 4 5, तो यहाँ पे नंबर ऑफ शेल्स इंक्रीज हो गया. देन इन द फर्स्ट पार्ट वी सेट द इनफिल एज 20%. तो ये 20% इनफिल है एंड दिस इज 40% इनफिल. ठीक है, डिफरेंस समझ में आ रहा है आप लोग को? देन इन द फोर्थ एंड द फिफ्थ डिजाइन हम लोग ने इन द थर्ड डिजाइन हम लोग ने टॉप सॉलिड लेयर 0 रखा था. सो इफ यू कीप द टॉप सॉलिड लेयर 0, दिस इज व्हाट यू गेट. ऊपर का आपका जो बॉडी है ये 0 लेयर, सॉलिड लेयर इज 0, द इनफिल्स आर विजिबल. Similarly, if you keep the bottom solid layer 0, this is the bottoms is visible. ठीक है, यहाँ पे अपने 100% रखा हुआ है. अगर हम लोग इसको 100% को अगर हम चेंज कर देते हैं 40, सॉरी दिस पार्ट को अगर हम इसको 80% को अगर हम 40 में लेके आते हैं, you'll be able to see each month better. ठीक है, तो फोर्थ वाले में हम लोग ने बॉटम सॉलिड हम लोग ने 0 रखा हुआ है. दिस इज द बॉटम. ठीक है, अब व्हाट इज द डिफरेंस कि हम लोग कब यूज करते हैं लेयर हाइट में डिफरेंसेस? टॉप सॉलिड लेयर, बॉटम सॉलिड लेयर एंड आउटर पेरिमीटर शेल्स. तो सॉरी, ठीक है, यहीं से एक्सप्लेन करते हैं. ठीक है, let's move this. Top solid, bottom solid हम लोगों ने इंक्रीज किया 9, this second model, and top solid layer is 6 7. and third first body में हम लोगों ने layer height इंक्रीज किया 2 3. okay, let's print it first and second. अब हम डिफरेंस देखेंगे. क्रॉस सेक्शन, सो अभी आपको डिफरेंस दिख रहा है कि ये एक मॉडल है जहां पे हम लोगों ने टॉप सॉलिड लेयर को इंक्रीज किया है अराउंड 5 and 6, एंड हम लोगों ने एक जगह है जहाँ पे हम लोगों ने 3 यूज किया है. तो डिपेंडिंग ऑन कि आपके कौन से डायरेक्शन ज्यादा स्ट्रेंथ लग रहा है, यू कैन एडजस्ट दैट सेटिंग्स कि आपको कौन से डायरेक्शन में ज्यादा सेटिंग्स. यहाँ पे ये थिकनेस उतना है, यहाँ पे नहीं है. इफ वी दोनों 0 कर देते हैं, आप लोग कंफ्यूज हो रहे हैं क्या?
यस सर, थोड़ा कंफ्यूज.
ओके, मतलब ठीक है, डोंट फोकस ऑन दैट। पहले आप लोग लेयर हाइट समझ लीजिए कि लेयर हाइट क्या है। लेयर हाइट कुछ नहीं, इसका रेजोल्यूशन है। लेयर हाइट अगर इंक्रीज होगा तो क्वालिटी डिक्रीज होगा, लेयर हाइट इंक्रीज होगा तो टाइम डिक्रीज होगा, लेयर हाइट इंक्रीज होगा तो कॉस्ट डिक्रीज होगा। ठीक है। आफ्टर दैट फर्स्ट इज लेयर हाइट, सेकंड इज द शेल की नंबर ऑफ शेल्स, जो हम लोग आउटर पेरीमीटर शेल से हम लोग यहाँ से कैलकुलेट कर रहे हैं कि कितना शेल्स हमारे को चाहिए। नंबर ऑफ शेल्स आपको क्लियर है?
यस सर।
हाँ, नंबर ऑफ शेल्स आपसे को क्लियर है। ठीक है। आफ्टर दैट देयर इज ए ऑप्शन कॉल्ड इनफिल, जहाँ पे हम लोग वेरी कर सकते हैं कि इन कितने परसेंटेज हम लोग इनफिल्स दे सकते हैं। इसके अंदर में और भी बहुत सारे ऑप्शन है। आप कहीं पे रेक्टेंगुलर चूज कर सकते हैं। आप जैसे कि हम लोग ने अभी सेकंड वाले प्रोसेस में हम लोग ने ग्रिड यूज किया है, थर्ड वाले में हम लोग ने इनफिल हम लोग ने ट्रायंगुलर यूज किया है 40%, एंड फोर्थ वाले में हम लोग ने हनीकॉम्ब यूज किया है 40%। तो यहाँ से देखेंगे, दिस इज हियर वी यूज ग्रिड, यहाँ पे हम लोग ने ट्रायंगुलर यूज किया, यहाँ पे हम लोग ने हनीकॉम्ब यूज किया। तो आप इनफिल अलग अलग चूज कर सकते हैं डिपेंडिंग ऑन द स्ट्रेंथ दैट यू नीड। इसका स्ट्रेंथ से काफी कुछ रिलेशन है कि
Which one is
कौन
the
से डायरेक्शन में आपको
strongest?
सप्लाई चाहिए। हेलो
Which one is the strongest, Ashish?
हेलो,
Yeah, Ashish. Which one is the strongest generally?
फास्ट हनीकॉम्ब
Honeycomb. Okay.
या हनीकॉम्ब इज ठीक है।
सर एक्चुअली वो जो इनफिल का साइज छोटा होने से मतलब मैटर करता है क्या? पैटर्न का जो एक हर ब्लॉक्स का अगर साइज कम हो तो ज़्यादा अच्छा है परसेंटेज?
नहीं, अगर इनफिल अगर कम देते हैं तो आपका बॉडी जो है वो लाइट बनता है, अगर हम लोग इनफिल ज्यादा देते हैं तो वो हैवी बनता है। स्ट्रेंथ इनफिल ज्यादा देने से इट्स डेफिनेटली सॉलिड, तो वो आपको ज्यादा स्ट्रेंथ देगा, एंड अगर वो इनफिल अगर कम रखते हैं तो वो थोड़ा स्ट्रेंथ आपको कम देगा। दैट्स द ओनली डिफरेंस इसमें। शायद मैंने आपको आंसर कर दिया है क्या?
हाँ,
यस
what he
सर।
wants to ask is like percentages में तो vary करेगा ही. In the same
हाँ
percentage, you said that honeycomb is the best, right?
हाँ हाँ, ठीक है। इट ऑल्सो डिपेंड कि आपको मॉडल किस तरीके से है या फिर प्रेशर किस तरीके से अप्लाई हो रहा है, वो सब में फर्क पड़ता है। बट आई वोंट गो इन डिटेल इन दैट पार्ट। ठीक है। तो हम लोग ने तीन चीज पढ़ा है अभी। सबसे पहले हम लोग ने लेयर हाइट पढ़ा है, देन आफ्टर दैट हम लोग ने पढ़ा है व्हाट इज नंबर ऑफ शेल्स। जितना नंबर ऑफ शेल्स ज्यादा होगा आपका आउटर पेरीमीटर पार्ट उतना स्ट्रांग हो जाएगा। देन द नेक्स्ट थिंग वी अंडरस्टूड इज द इनफिल, कि इनफिल परसेंटेज ज्यादा होने से बॉडी का वेट ज्यादा होता है, टाइम ज्यादा लगता है, एंड स्ट्रांग ज्यादा होता है। ठीक है। आफ्टर दैट इज सपोर्ट्स। सपोर्ट्स हम लोग ने डिफाइन किया था आपको कि सपोर्ट्स किस तरीके से जनरेट करते हैं। मैंने आपको बताया कि अगर इस डायरेक्शन में अगर हम प्रिंट करते हैं तो इतना सपोर्ट बन रहा है। लेट्स से कॉपी दिस, इसमें अगर हम उसका डायरेक्शन चेंज कर दें दिस पार्ट में, यहाँ पे अगर हम सपोर्ट जनरेट करते हैं तो दिस सपोर्ट्स। ठीक है। नाउ लेट्स अंडरस्टैंड दिस पार्ट, ओरिएंटेशंस। सो ये इस तरीके से प्रिंट हो रहा है इन दिस पार्ट। नाउ लेट्स से अगर आपको प्रेशर अप्लाई करना है इस पार्ट पे, सॉरी, ओके, अच्छा, इस डायरेक्शन में हम लोग एक प्रेशर अप्लाई कर रहे हैं एंड इस, ओके, यहाँ से देखिए आप, ठीक, अगर हम लोग यहाँ पे प्रेशर अप्लाई कर रहे हैं, यहाँ पे प्रेशर अप्लाई कर रहे हैं, तो जो इसका ओरिएंटेशन है प्रिंट होने का इज हॉरिजॉन्टल, तो यहाँ पे प्रेशर इजीली हैंडल कर लेगा बिकॉज देयर आर लॉट्स ऑफ पार्ट्स। लेकिन अगर इसी पार्ट में अगर आपको यहाँ पे अगर प्रेशर लगना है, यहाँ पे अगर आप प्रेशर लगा रहे हैं और यहाँ से प्रेशर लगा रहे हैं आप, सो दीज पार्ट्स आर प्रिंटेड इन दिस डायरेक्शन, तो ये पार्ट जो है ये 3D प्रिंटेड है, इट विल गेट स्टिक टू इट, बट यहाँ पे आपको प्रेशर कम मिलेगा, इट विल बी इजीली ब्रेकेबल। समझ रहे हैं? जैसे कि समझाया ऑनलाइन।
So what Ashish wants to say is like that portion will be weak in resisting shear force, right?
Yeah.
And not only shear force, even compressive force also. Compressive force will be almost similar, they will act similar, but in case of
Yeah.
shear force, that part will get sheared away, right?
Yes sir.
Because they are layer by
Sure.
layer, they are not like
Because they are layer by layer. हाँ.
So
And in this part में हमारे ये वाले part में हमारे को we'll get a stronger part here if you want to apply this pressure. जो सर बोल रहे हैं, that's the exact thing I want to convey. कि the orientation of print depends, like it किस डायरेक्शन में आप प्रिंट कर रहे हैं, द ओरिएंटेशन, वो आपको स्ट्रेंथ, आप कौन सा स्ट्रेंथ, कौन से बॉडी पार्ट में आपको ज्यादा स्ट्रेंथ लगता है, दैट वेरीज। ठीक है, आफ्टर दैट सपोज हम लोगों ने बता दिया टेम्परेचर। ओके, व्हाट इज टेम्परेचर? सो एज आई टोल्ड यू, एज आई शोड यू कि वहां पे एक हीटेड बिल्ड प्लेटफॉर्म का ऑप्शन था, हीटेड बिल्ड प्लेटफॉर्म। ठीक है, हीटेड बिल्ड प्लेटफॉर्म का क्या मतलब होता है कि जिस प्लेट पे बन रहा है, it has a heater connected to it and we need to give temperature to that part. So जब भी हम लोग कोई पार्ट को प्रिंट कर रहे हैं, the filament needs to get stick to the body. ठीक है, अगर वो अच्छे से नहीं लगेगा तो it will come out. So there are some materials, there are lots of materials available, जैसे कि PLA है, ABS है या फिर पॉलीकार्बोनेट है. So PLA doesn't need a heated bed. उसको 50 डिग्री टेम्परेचर पे हम लोग उसको प्रिंट कर सकते हैं और वी कैन स्विच इट ऑफ आल्सो। देन इन ABS is a material which needs a heated bed of 100 डिग्री सेल्सियस। उसको हीटेड एनवायरनमेंट चाहिए, आसपास का एनवायरनमेंट इट नीड्स टू थोड़ा हॉट होना चाहिए ABS प्रिंट करने के लिए। So that's why we have, for ABS we'll need 100 degree Celsius. Similarly in polycarbonate it needs much more, 120, 130 degree Celsius. So every filament has its own specifications. According to the filament, according to the raw material that you're using, आपको heated bed का temperature देना है. For PLA, it is 60 or 50 recommended. ठीक है. Then there's one more. There are two heaters being used in a 3D printer. One is the heated bed, and the another one is the extruder. ठीक है. तो जो extruder है, अब जैसे PLA जैसे हीटेड बेड, हर मटेरियल का प्रिंट होने का टेम्परेचर अलग अलग है। जैसे ABS गेट्स प्रिंटेड इन 200 डिग्री सेल्सियस, सॉरी PLA गेट्स प्रिंटेड इन 200 205 डिग्री सेल्सियस, ABS प्रिंट्स इन 240 245 डिग्री सेल्सियस एंड पॉलीकार्बोनेट गेट्स प्रिंटेड इन 300 310 डिग्री सेल्सियस। सो आपको अकॉर्डिंग टू द रॉ मटेरियल यू हैव टू डिसाइड कि आप कितना टेम्परेचर में आपको प्रिंट कर रहे हैं। That is heated bed and extruder temperature. Then a cooling fan. I'll show you the difference when you use cooling fan and when you don't use cooling fan. After we have done with this, I'll show you a print where we have used a cooling fan and we have in one print we have used cooling fan, in one print we have not used cooling fan. Speed vary करता है। स्पीड्स जो है वी कैन change the speed of a print, any print 60 mm per second, 60 mm per second or 3600 mm per minute is the standard printing speed. 3600 mm per second. स्पीड से भी बहुत वेरी करता है कि आपका टाइम कितना लगेगा कितना नहीं लगेगा. Okay. तो आई थिंक टाइम भी हो गया है 7 बज गए एंड today's class I think I got you students a little bit confused किस तरीके से हो रहा है सब कुछ. Tomorrow I'll be much more prepared and I'll be like because practically समझाना अलग है online समझाना थोड़ा सा अलग है. So online समझाने में मैं थोड़ा सा चूक गया. Tomorrow I'll be much more prepared and I'll come with a presentation to explain you in details and we'll be able to generate a G code tomorrow. And sorry like I failed like
No, no, you
आप
are
लोगों को
good.
समझ में आया नहीं
No
आया
problem, sir.
तो
No
please.
problem.
Okay.
So I saw your the room where you print. So
Yes sir.
it seems 50 students cannot be accommodated there at a time.
50 students. 50 students cannot get accommodated. Like I have a space of around 40, 30, 30, 35. Let's see.
Okay, so I have to be selective while selecting the students, or maybe we can have two batches. Like, is it okay for you? Like on the same day, 1 hour each, two batches.
Yeah. I think 50. Yes sir. No problem.
It's okay, no? Then we'll try to
Hmm.
accommodate we try to manage in one batch only if the number of interested participants are less than 40. Otherwise,
Hmm.
we have to split in two groups. And have you given a thought about the day where you can demonstrate?
Sir, actually my dates are really tight right now.
Yes,
So
understand. But still,
I have to check it once again after like on
we
9th
will
or 10th
not
of February do it.
not more than 3 hours, that I can guarantee. So
Okay.
at least 3 hours if you can provide. So you said 9th or 10th, right?
Yeah.
9th or 10th. Okay. So because the students are now not residing at hostel, all of them, because of this corona
Mm.
situation, so they are scattered. Some are at home, some are at PG. So they will
Okay.
need at least 2 days of notice before we plan this. So
Okay sir.
you let us know if it is possible on 9th or 10th or whatever the date is.
Okay sir, no problem.
Okay. So
ठीक है.
anyway, so thank you again, Aashish. I know how busy you are, but still you are taking your time out and giving your best. And of course, you are not a professional teacher, so still you are trying best to give this kind of details in the online mode. We appreciate it. And again, thank you. See you tomorrow at 5.
Okay sir. Sorry. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much.
Thank you, sir.